Hi kids, it's Dr. Rones here with your Objective 77 lesson. We are going to be solving linear equations, this time by combinations, and this is going to be a great lesson. I hope you enjoy it as much as I enjoy teaching this one. It's a really fun one. Before I get started though, I will start with my disclaimer. This isn't going to be the best lesson. It's not the same as what other math teachers might teach. It's going to be my best, I suppose I should say, and it's suitable for our students who are learning from home. So if another person wants to teach a different way, that's totally okay. This is just for our purposes. So again, we're starting with combinations today. We have been studying linear equation systems of them. What that means is when you're trying to simultaneously solve more than one equation at one time, for often more than one variable as well. So the ones that we are going to be working with are two equations, a system of two linear equations and two different variables. So this is going to accomplish the same exact thing as solving systems of equations by substitution. That's our previous lesson. We also demonstrated how it also looks when we solve by graphing in that lesson. So if you look here, this is an example that we are going to work through in great detail on this whole front of the page. And then we'll do several of them on the next page a little bit more quickly. But for this first page, we will really dissect this into more detail here. So step number 1 of 6 is that we are going to arrange the equations so that the like terms are in columns. And so this has already been accomplished for us in this example, because you'll see that the x's line up, the y's line up, the equals line up, and then the constants all line up. So that's what that means about by arranging the equations with like terms in columns. Columns means it's vertically the same variable. Okay. Step number 2 says to multiply one or both of these equations so that the coefficients are opposites. And conveniently, that has also been done for us as well. You will see here that these y's, right, are both with a 3, but one's with a positive and one's with a negative. So therefore they are opposites. And in the next step, those are going to be eliminated, making our process a little bit simpler. For the next step, it says to add the coefficients together, and that's going to get rid of one of the variables. So you may not have realized this, but you can add equations together. So we're going to turn this into a simple addition problem. And like we said before, a positive 3y and a negative 3y come out to 0. They're nothing. So they're going to be canceled out. So 4x and 2x make 6x equals 16 plus 8 is 24. And now 6 is being multiplied with x. The reverse of multiplication is division. What I do on one side, I do to the other. 6 over 6 is 1x equals 24 over 6 is 4. So I've now solved for the other variable. And now this next step is reminiscent of our previous lesson, where we're going to sub in what we just learned to one of the original equations. So now that I know that x has a value of 4, I can plug that into either of these other equations. I'm just going to pick this one. So instead of 2x, I'm going to say 2 4s, because x has a value of 4. Minus 3y equals 8. So now I only have one variable in my equation. So I can solve for the y. 2 4s is 8. The reverse of a positive 8 is a negative 8. What I do on one side, I do to the other. 8 over 8 are 0. So I'm left with negative 3y equals 8 minus 8 is 0. Y is with being multiplied with a negative 3. The reverse of multiplication is division. What I do on one side, I do to the other. Negative 3 over negative 3 is 1. 0 divided by anything is 0. All right. And then our next step hopefully has become automatic in practicing the previous lesson. We are going to combine the x and y values into a coordinate. X comes first and y comes second. So what that means is if I substitute 4 in for both of the x's, 0 in for both of the y's, both of those equations will balance out. What that also means is if I write both of these equations in slope-intercept form and graph them, those two lines will intersect at point 4 and 0. And then the last step is to check our work by substituting those values in to make sure that they actually balance out. So I'm going to rewrite those equations here. So 4x plus 3y equals 16, and the other one was 2x minus 3y equals 8. Now if you can do this in your head, that's great. You don't have to write it all out, but for the sake of a demonstration, I will show you this. So again, 4's are our x's, so instead of 4x, I'm going to say 4 4's. Instead of 2 x's, I'm going to say 2 4's. Y is 0, so minus 3 zeros equals 16. Minus 3 zeros equals 8. Let's see if these balance out. 4 4's is 16. Minus 3 zeros is 0. Yeah, 16 minus 0 is 16. 2 4's is 8. 3 zeros is 0. 8 minus 0 is 8. So yeah, both of these balance out. So this is our solution to the system of equations, and we found it by combinations. You could have started out by substitution from the very start. You could have solved for one of these equations for one variable, but you'll see if I had done that, this would be kind of messy. For example, if I wanted to solve for this x, I would have to multiply everything by 2, and if you divide this 3 by 2, you'd have to be working with an improper fraction while you're trying to solve that. So that's why some people prefer this method, is it kind of saves from some messy math. So that was a long example. We can do some abbreviated ones, and we will start easy and we will get more difficult progressively as we go. Okay, so in this, I'll try to keep with the same color coding scheme too. Alright, so again, step number 1 is to arrange the equations so that they are in columns. So the x's are over the x's, the y's are over the y's, the equals over the equals, the constants over the constant. Maybe I shouldn't have drawn those little dots over the top, sorry about that. Okay, step 2 is to multiply one or both of those equations so that you have opposites. I didn't have to do that again this time. We'll do that eventually. But a positive y and a negative y are opposites. In a moment they are going to zero out, and that is step 3. A positive and a negative y are nothing. Now I can add this together. X and x are 2 x's. 5 and 7 make 12. X is being multiplied by 2. The reverse of multiplication is division. What I do on one side, I do to the other. 2 over 2 is 1 equals 12 over 2 is 6. So now that I know what x equals, I can put that into either of the equations at the top. I'm going to pick this one to solve for y. Instead of x, I'm going to put 6 plus y is 5. Now I can solve for y. The reverse of a positive 6 is a negative 6. What I do on one side, I do to the other. 6 minus 6 are nothing, so y equals 5 minus 6 is negative 1. And I can combine these two to make a coordinate solution, so 6 and negative 1. And then the last step is to substitute these values in. If 6 is x and y is negative 1, x and y, 6 minus 1 is 5, yep. 6 minus a negative, so that's plus. 1 is 7, yep. That is also correct. So I know that 6 and -1 satisfies both equations. It would be the intersection point of those two lines. Okay. All right, as we go, it's going to get a step more difficult. I'll also remind you, as you are going through this lesson, feel free to stop and rewatch as you need to. Also, feel free to go ahead of me if you would like. This is for your purposes, so there's no need to follow what I'm doing exactly. Do watch this as you need to. Okay, again, step number 1 is to arrange your equations in columns. So here I have the x's and the y's, the equals, and the constants at the end. I probably should have shifted this over a little bit, but they're going in the same order. Okay, and then we're going to multiply one or the other so that we have opposites. Again, we don't have to do that. 3x and -3x are going to cancel out. So step number 3 is to add them up. I'm going to put in a tiny plus sign. So 3 minus 3 is nothing. So y and 4y are 5y's. 6 plus 9 is 15. Y is being multiplied by a 5. The reverse of multiplication is division. What I do on one side, I do to the other. 5 over 5 is 1. Y equals 15 over 5 is 3. And now that I know what y equals, I can put it into either of the other equations to solve for x. Instead of y here, I'm going to put in what y is equal to, which is 3 equals 6. Alright, the reverse of a positive 3 is a negative 3. What I do on one side, I do to the other. 3 minus 3 is 0. So I'm left with 3x is 6 minus 3 is 3. X is being multiplied with 3. The reverse of multiplication is division. What I do on one side, I do to the other. 3 over 3 is 1. X equals 3 over 3 is also 1. And now that I have these both, I can put them together into a coordinate that will satisfy both equations. So if this is my x, 3 x's would be 3 plus 3, yep, that's 6. Negative 3 x's, that'd be negative 3 plus 12, yep, that would also be 9. So that is our solution. Good, good. Okay. I would like to encourage you to go a step ahead of me and attempt this one. Give this a pause and then start it up again when you are ready. Hopefully you've done that. So here are the x's, the y's, the equals, and the constants. So the first step is done once again. Second step again is to have opposites. So I have a negative 3y and a positive 3y. So those are already opposites as well. So step number 2 is done. Step number 3 is to add these up. There's really no room for my plus sign. Okay. Negative 3y, add 3y back is nothing. So I'm left with 2 x's and an x is 3x. Negative 16 plus 10 back is negative 6. X is being multiplied with a 3. The reverse multiplication is division. What I do on one side, I do to the other. 3 over 3 is 1. X equals negative over positive is a negative. 6 over 3 is 2. And now that I know what x is, I can sub it into either of these equations. I chose the bottom one because it looks a little bit easier to me. So I have x plus 3y is 10. So again, here's the value of x. I didn't write the variable x. The reverse of a positive negative 2 is a positive 2. What I do on one side, I do to the other. So negative 2 and 2 zero out. So I'm left with 3y is 12. These are being multiplied. The reverse of multiplication is division. What I do on one side, I do to the other. 3 over 3 is 1. Y equals 12 over 3 is 4. And we have our coordinate again. Negative 2 and 4 is our solution, is where these two lines are going to intersect. And I can double check that. 2 negative 2's is negative 4 minus 12, yep, is negative 16. Negative 2 plus 12, yep, is 10. So that works. I did that kind of quick. If you need to write that out, that's totally fine, or use a calculator. That's fine too. Okay. Let's move to the next section where less of these steps have been done for us. I feel like we're good and warmed up. We can increase our difficulty a little bit more. Okay, but again, the first step has been done for us. We have the x's, the y's, the equals, and then the constant at the end, so that's already been done. However, now I don't have opposites already made. You'll see I have a negative 2, but only one x there. I have a 3 and a negative 4 there, so they're not going to cancel out. So what I will do is I am going to find some variables to work with where I can multiply one of these equations so that they cancel each other out. So let's look at the x's here. I would need a positive 2x to cancel out a negative 2x. So I can turn this x into 2x's by multiplying the whole equation by 2. It's like a big distributive property. 2 times x is 2x. 2 times negative 4y is negative 8y equals 2 times negative 12 is negative 24. And now that I've done that, I don't need that line anymore. So I'm focusing on that top line and the bottom one that I just wrote in. And now I have variables that will cancel each other out. So negative 2 and a positive 2 come out to nothing. 3y less 8y is negative 5y's. Should have written my little plus business here. Equals 14 minus 24 is negative 10. And y is being multiplied with a negative 5. Reverse of multiplication is division. What I do on one side, I do to the other. Negative 5 over negative 5 is 1. Y equals negative over negative is a positive. 10 over 5 is 2. And it's just like the substitution process again. So I'm going to use this guy. I could have used that one, but I kind of crossed it out, so that was not maybe as smart. So negative 2x instead of y, I'm going to put plus 3 2's equals 14. And then negative 2x, 3 2's is 6. The reverse of a positive 6 is a negative 6. What I do on one side, I do to the other. So negative 2x's are now 14 minus 6 is 8. X is being multiplied with a negative 2. Reverse of multiplication is division. What I do on one side, I do to the other. Negative 2 over negative 2 is 1. X equals 8 over negative 2 is negative 4. So my solution appears to be negative 4 and 2. Make sure you write the x first. So negative 2, negative 4 is 8, plus 6, yep, is 14. Can I read that? Negative 4 minus 8, yep, is negative 12. So that balances out. Okay, so the step that we added in that one is we had to manipulate one of the equations so that it caused two of the variables to cancel out. Or one of the variables to cancel out, of the two, I should say. Let's try another one. The first one might have blown your mind a little bit. Do another set and hopefully that will clarify things. Okay, so again, first step is to line up your x's, your y's, equals, constant, so that's already done for us. Step number 2 is to change one or both of those equations so that you have variables that cancel out. So here I have 3 and 5. My common multiple there would be 15, but I'd have to change both of them. So instead, I see I could create opposites if I multiplied this y by negative 2. So I'm going to multiply this whole top row by negative 2. So negative 2 times 3x is negative 6x. Negative 2 times y is negative 2y. Negative 2 times positive 4 is negative 4. Alright, so I've dealt with that. So now I have a new equation to use. And now I have my opposite variables that will cancel out. 2 minus 2 is 0. So I'm left with 5 minus 6y is negative y equals 5 minus 4 is 1. And we know when we get a variable that's negative as a result, we can multiply each side by a negative 1, or flip the signs on both. And now I can substitute that x into one of the original equations. I'm going to pick this top one even though I crossed it out. Instead of 3 x's, I'm going to say 3 negative 1's plus y is 2. And then going ahead and solve. 3 times negative 1 is negative 3, and y is 2. And as we're doing this, you can see why it's so important to be keeping up on your math so that you can do all of these things. Solving multi-step equations was a long, long time ago. However, it's very relevant to what we are doing now. So if you're getting stumped on the solving equations part, it might be worthwhile to go back to some of those old lessons. Okay, so we ended up with negative 1 and 5. 3 times negative 1 is negative 3, plus 5 is 2. This would be negative 5 plus 10, yep, is 5. Good. All right, we still haven't had an equation where we have to do all of the steps yet. So let's see if we get to that point here. I don't think we will in this next row. We will at the bottom. Okay. So again, we have the x's and then the y's and the equals and the constants. So that part is good for us. The second part is to multiply one or both of the equations so that one of the variables cancel out. I have 3 and 7. 3 isn't going to be, I can't multiply 3 by a whole number to get 7. Can't do that with 2 and 3 either. But I could create negative 6 and positive 6 if I multiply the whole top row by 2 and the whole bottom row by 3. That would make negative 6 and positive 6. So let's try that. 2 times 7x is 14x. 2 times negative 3y is negative 6y. 2 times negative 5 is negative 10. And now I can do the next row. 3 times 3x is 9x. 3 times 2y is 6y. 3 times 11 is 33. Hey, look what we did. We have variables now that cancel out. A negative 6 and a positive 6 come out to nothing. 14x and 9x are 23x's. Negative 10 plus 33 is 23. Ooh, I can predict what this answer is going to be. It's being multiplied. The reverse of multiplication is division. What I do on one side, I do to the other. 23 over 23 is 1. X equals 23 over 23 is 1. Alright, now that I know that, I can put that into one of the equations that we started with. I recommend using one of the original ones, just so we know it's correct. It's not a rewrite. And we're just going to solve it like normal. 3 ones is 3. And then reverse of a positive 3 is a negative 3. What I do on one side, I do to the other. 3 minus 3 is nothing. So 2 y's are 11 minus 3 is 8. They're being multiplied. Reverse of multiplication is division. What I do on one side, I do to the other. 2 over 2 is 1. Y equals 8 over 2 is 4. Repeat all these steps the same way each time, hopefully, so that they get burned on your brain. Someday, years from now, when I'm just a memory in your math education, perhaps you'll be saying these same phrases. 7 ones is 7, minus 12 is, yep, negative 5. 3 ones is 3, plus 8, yep, is 11. So that's the solution. Okay. Now would be a good time to try one on your own. Again, consider pausing this. See how far you can get and hit start. Again, when you're ready. Hopefully you did that. So, I have all of my things lined up as I should. X's, Y's equals and the constant, so I don't need to do that. Now I need to multiply one or both so that I have variables that cancel out. Well, I could create 6 and negative 6 here. I could create 35 and negative 35 there. I'm going to go with the 6's because that's a smaller number. So I think I'm going to multiply the top by 2 and the bottom by 3 to get 6's. But here's the deal. If I multiply this by 2, I'll get negative 6. If I multiply this by 3, I'll get negative 6. And negative 6 and negative 6 do not cancel out. Negative 6 and negative 6 are negative 12. So I need to multiply one of these by a negative so that I end up with a positive 6 and a negative 6. Negative 6 times negative 3 is positive 6x. Negative 2 times positive 7y is negative 14y. Equals negative 2 times negative 1 is a positive 2. And that one's done. 3 times negative 2 is negative 6x. Oh, we created the ones that are going to cancel out. 3 times 5y is 15y. And 3 nothings is nothing. And I can add this up. 6 plus 6 is nothing. Negative 14 plus 15 back is a singular y equals 2 plus 0 is 2. And so now I can sub that in. I'll put it in here. Negative 2x plus 5 instead of y, I'll put in 2. Okay, and continue solving. 5 2's is 10. Oops, got a little crazy there. Reverse of positive 10 is negative 10. What I do on one side, I do to the other. 10 over negative 10 is nothing. Bring down negative 2x equals 0 minus 10 is negative 10. These are being multiplied. Reverse multiplication is division. What I do on one side, I do to the other. Negative 2 over negative 2 is 1x equals. Negative over negative is a positive. 10 over 2 is 5. And so it appears that our solution is 5, 2. These are getting more complicated to sub in. Negative 3 times 5 is negative 15 plus 14 is, negative 1. Negative 10 plus 10 is 0. Yeah, that's good. All right. We've done this whole page and we still haven't had one yet where we have to do our first step. But we finally have in our challenge that opportunity. I'm going to fold my paper. So that we can do that. Okay, before I show you, I want to challenge you to do as much of this ahead of time as you possibly can. Take a guess. Even though I haven't taught this directly to you, you do know enough that you could do this without me. Okay. So I need my y's and my x's to line up, but I have a y over an x here, and I have x's over y there, and that's not okay. Okay, and I can't just, write things in different places. I have to mathematically adjust this. So let me start here. 3y equals 5x plus 15. So let's rewrite this so that my x's are also on the left. So I'll move a positive 5x with a negative 5x. What I do on one side, I do to the other. 5x minus 5x is nothing. So I'm left with negative 5x plus 3y is 15. Okay, so x's then y's equals my constant. And I'll bet that I could do the same thing over here with the second one. I had 6x is 2y minus 18. Let's bring the y's to the left. The reverse of a positive 2y is a negative 2y. What I do on one side, I do to the other. 2y minus 2y is nothing, so I'm left with, I'm going to bring down my x's first. So 6x minus 2y is negative 18. So now I have two equations that go x's, then y's, then equals, then the constant. So I'm just going to write them one over another. 6x minus 2y equals, as we're going here, this does tend to go all over the page, so be careful when you're copying things down again. Be neat with your work. Okay, they're all lined up. That's great. Now I need to multiply one or both so that I have variables that cancel out. That would be 30 and negative 30, or 6 and negative 6. I'd rather deal with the small ones. So let's multiply the top by 3 and the bottom by 2. So 3 times 6x is 18x. 3 times negative 2y is negative 6y. 3 times negative 18 is, negative 54, I think. 36, 40, yep. And then I repeat, these guys are gone. And then I repeat. So 2 times negative 5 is negative 10x. 2 times 3y is 6y. 2 times 15 is 30. Great. And now I can add these up to eliminate those y's that are opposites. Negative y and a positive y are nothing. So I'm left with 18 minus 10x is 8x equals negative 54 plus 30 back is negative 24. Y is being multiplied with 8. Reverse of multiplication is division. What I do on one side, I do to the other. 8 over 8 is 1. Y equals a negative over a positive is a negative. 24 over 8 is 3. And now that I know what y is, I can sub that into one of the equations to solve for x. I'm going to use one of the original ones. I like this one better. Okay. Instead of 3y's, I'm going to say 3 negative 3's because y is worth negative 3. Everything I sub in, I put in parentheses so that you can tell that it came from something else. I'm going to zoom out so you can see all this. All right, equals